Okay, greetings everybody. This is the second video from my Chapter 7 lecture notes, Part 1. So it's the second video involving Part 1 of Chapter 7. Now, so we know that work is equal to FD cosine theta, where again, F cosine theta gives you the component of the force that's parallel to D. Okay, perpendicular forces do no work. By that, think of this example, Fn and mg do no work because they are at 90 degrees to D. The work done by friction, the work done by Fk is always negative because Fk is always 180 degrees from the direction of the motion. It's exactly opposite. And you all know cosine of 180 is negative 1. So the work done by friction is always negative. Now let's look at this figure here on the right. We have four situations. We have in each case you have the applied force F, and instead of D, they're using this delta R for the displacement. Don't let that throw you. In other words, in panels A, B, C, and D, the object is moving a distance of delta R in the positive x direction. You can call that distance D. You can call it x. You can call it L. They call it delta R. Now we want to rank the situations in the order of the work done by the force from most positive to most negative. Well, we know right away that the work done in panel A is 0, because in panel A, F is perpendicular to delta R. Perpendicular forces do no work. Okay, so that's 0. Now remember, we want most positive to most negative. Well, B is going to be the most negative, because in this case, F is exactly 180 degrees to delta R. So that's the most negative. Now D, the work is going to be negative, because notice that vector, that's the component of F that's in this case anti-parallel to delta R. But notice in panel D, the x component of F is less than this. So most negative is B. Then after that is D, 0, A is 0. And then the most positive is C, because F, here they're parallel. And the cosine of 0, remember, parallel means the angle between F and delta R. Theta is 0. So most positive is C. Then you have A is 0. Then D is negative, but B is more negative. So that's what we mean when we say C, A, D, and B, because we want it from most positive to most negative. So, and remember 0, a work done of 0, remember 0 is greater than any negative number. So when you're ranking them, it's C, A, D, and then B. Because the work done by D is negative, but the x component of F is less than here. F is entirely in the x direction, or negative x direction, excuse me. So the work done by D is negative, but it's not as negative as when F and delta R are exactly 180. Well, let's now throw in some actual numbers. In this example, you have a man, he's cleaning the floor, and he's pulling a vacuum with a force of 50 newtons, and the force makes an angle of 30 degrees with the x-axis. And again, this D indicates, it's not complicated. So, hey guys and gals, that's the direction that the vacuum is moving. So the forces acting on the vacuum are the applied force F, the 50 Newton force. And it makes an angle of 30 degrees with respect to D. And we also have the normal force on the vacuum, Fn, and the weight of the vacuum, mg. Well, we don't need to reinvent the wheel. Fn and mg do no work. And the work is Fd cosine theta. Very simple. Work is Fd cosine theta. Units are all good. The force is 50 newtons. D is 3 meters, because it's saying you're being told that it's displaced 3 meters to the right. The magnitude of the force is 50 newtons. The angle theta is 30 degrees. So work is Fd cosine theta. So that's Fd cosine theta. And 50 newtons times 3 meters times the cosine of 30 will give you 130, and we know that the MKS unit of work, it's always expressed as a joule, which is abbreviated with a large J. And again, we know Fn and mg do no work. Why? Because they are perpendicular to d. Cosine of 90 is 0. Now we don't. I won't always keep repeating that after this video. Second nature. Perpendicular forces do no work. So again, work is Ft cosine theta. Where again, F cosine theta gives you the component of the force that's parallel to d, i.e. right here. Alrighty, let me go ahead and save this video and get it posted.